Today, we're diving into a really fascinating new AI model called GLM-4.7 Flash. It's taking a pretty different approach to how we build artificial intelligence. Now, we're going to break down exactly what makes it so special.
So just think about this for a second. What if you could have the raw power and performance of a massive AI model, but with the speed and the efficiency of something way smaller? Well, that's the big question this new model is trying to answer.
All right, here's how we're going to tackle this. First, we'll get properly introduced to GLM-4.7 Flash. Then we'll look under the hood at the clever tech that gives it that amazing balance of power and efficiency. After that, the fun part, we'll put it through a really tough coding test, check out its advanced reasoning skills, and finally, give our verdict on where this specialist AI truly shines.
So, GLM-4.7 Flash, it's a big deal. But its real claim to fame, its true innovation, is how it hits this perfect sweet spot between top-of-the-line performance and being super efficient to run.
Now, how in the world does it pull this off? Well, the magic is really all in its architecture. So let's peel back the layers and see what makes this thing tick. The key here is a design called Mixture of Experts, or MO for short. Now think of it like this. Instead of having one giant brain trying to know absolutely everything, you've got a whole team of specialists. When a problem comes in, let's say it's a coding challenge, the system is smart enough to call on only the 2 or 3 experts that are best suited for that job. The rest of the team, they just sit back. And that is the secret to its incredible efficiency. You know, on paper, this thing is a beast. It has a grand total of 30 billion parameters. You can think of those as the individual connections in its brain, and that's where it gets all its raw power and knowledge from.
But, and this is the brilliant part, thanks to that mixture of experts architecture we just talked about, for any one task, it only needs to activate about 3 billion of those parameters. This just perfectly shows off the efficiency. You get the knowledge of a massive 30 billion parameter model, but with the speed and cost of a much smaller one. It's kind of like having your cake and eating it too.
And this efficiency, it translates directly into some seriously impressive real-world performance. I mean, look at these benchmarks. It really holds its own and in some cases just blows the competition away. On the SWE bench, which is a super tough software engineering test, it stores a 59.2. That's miles ahead of its peers. You know, the fact that it doesn't win on every single metric is actually a good thing. It shows they're being transparent, and it proves that this is a serious contender where it really counts, especially in those technical fields.
Okay, benchmarks are one thing, but how does it actually perform on a practical, really complex task? We decided to put its coding skills to the ultimate test with a challenge that shows not just its skill, but its ability to think, and crucially, to recover from its own mistakes.
The test was this. Create a single, self-contained HTML file with an animated rocket flying across the screen. Simple enough, right? Well, the first attempt produced code, but it just didn't work. Nothing happened. And this is where most models would just give up. But not this one. GLM-4.7 Flash actually started a self-correction process, analyzed its own failure, and came up with a new version. The final result? A complete success. A smooth, physically accurate animation that worked perfectly.
And get this, during that self-correction, the model generated this sort of internal monologue, its chain of thought. It actually reasoned that blaming the user was a bad idea, and just assuming its own code was totally wrong was also a bad approach. This shows a seriously sophisticated level of problem solving. It's not just guessing, it's logically diagnosing its own errors to find a real solution. That's pretty amazing.
So to push it even further, the next challenge was to build an entire landing page for a fake dating app. We're talking multiple sections, specific design instructions, and it had to be mobile-friendly. The result was, frankly, astonishing. It produced this beautiful, fully functional, and responsive web page that followed every single instruction we gave it, right down to the color scheme and layout. A truly impressive display of its coding power.
Okay, so we've established it's a brilliant coder, but its skills go way beyond just writing new code. Let's see how it handles other kinds of complex technical reasoning.
For the next test, we gave it a complex, but really poorly written SQL query. The model didn't just run it. It analyzed it, like a senior database administrator would. It immediately spotted the performance problems, things like nested subqueries and inefficient joins. And then it correctly rewrote the entire query using advanced techniques like common table expressions, making it way more efficient.
And finally, a true test of its logical deduction and world knowledge. This is a multi-step riddle that's designed to connect completely separate pieces of historical trivia. It's the kind of thing that's built to confuse an AI that can't hold and process multiple logical steps at the same time.
So here's how it solved it. Instead of just guessing, it systematically deconstructed the entire riddle. It broke the problem down into two separate lines of inquiry. One started with the 42nd U.S. president, and the other started with the first Prime Minister of Canada, and it just logically followed the family tree for each one.
By logically piecing together the results from its deconstruction, it arrived at the correct answer: Elisha. Now, this shows a powerful ability to perform what's called multi-hop reasoning, and that is a key indicator of some seriously advanced intelligence.
All right, so after seeing it code, optimize databases, and solve these crazy riddles, what is the final verdict on GLM 4.7 Flash?
Well, the picture that emerges is incredibly clear. Its strengths are just profound in technical areas. Advanced coding with that super rare ability to self-correct, complex logical reasoning, and deep knowledge in things like SQL optimization. But it's not a master of everything. When we tested it on multilingual translation across dozens of languages, its performance was pretty inconsistent. This just shows that's not its area of expertise.
And that brings us to the most important point. GLM 4.7 Flash isn't trying to be the one AI that does everything for everyone. Instead, it's positioning itself as a powerful and efficient specialist. So if your task involves code or logic or any kind of deep technical problem solving, this model is absolutely a top-tier performer.
This all leads to a final, crucial insight. As AI keeps evolving, we're seeing a shift away from just all-purpose generalists. The future seems to be pointing towards a new wave of these focused experts, just like this one. The real opportunity now lies in identifying those complex, specialized problems that are just waiting to be solved by an AI that was built specifically for that task.